Few sensations are as abrupt and startling as the sharp, icy pain of a brain freeze. Known scientifically as sphenopalatine ganglioneuralgia, this phenomenon occurs when something cold, like ice cream or a frozen drink, comes into contact with the roof of your mouth or the back of your throat. Within seconds, a throbbing headache sets in, leaving you clutching your head and wondering why something so enjoyable can cause such discomfort. But what exactly causes brain freeze? And why does it happen so quickly? In this exploration, we'll dive into the science behind brain freeze, how it works, and what you can do to prevent or alleviate it. What is brain freeze? Brain freeze, also referred to as an ice cream headache, is a type of headache that occurs when you consume something cold too quickly. It typically lasts for a few seconds to a minute, though for some people the pain can linger a bit longer. The sensation is often described as a sharp, stabbing pain in the forehead or temples, though it can also radiate to other parts of the head. Despite its name, brain freeze doesn't actually involve the brain itself. Instead, it's a response triggered by the rapid cooling of the blood vessels and nerves in the roof of the mouth and the back of the throat. This sudden temperature change sets off a chain reaction in the nervous system, leading to the characteristic pain. The science behind brain freeze. To understand brain freeze, we need to look at the anatomy and physiology involved. The key players in this phenomenon are the blood vessels, nerves, and the brain's interpretation of signals. 1. The role of blood vessels. When something cold touches the roof of your mouth or the back of your throat, the blood vessels in that area constrict rapidly. This is a normal response to cold as the body tries to conserve heat and maintain its core temperature. However, the sudden constriction is followed by an equally rapid dilation, widening of the blood vessels as they attempt to restore normal blood flow. This quick change in vessel size is thought to trigger the pain receptors in the surrounding tissues. 2. The nervous system's response. The nerves in the roof of your mouth, particularly the trigeminal nerve, play a crucial role in brain freeze. The trigeminal nerve is one of the largest nerves in the head and is responsible for transmitting sensory information from the face to the brain. When the blood vessels constrict and then dilate, the trigeminal nerve senses this change and sends pain signals to the brain. 3. Referred pain. The brain sometimes struggles to pinpoint the exact source of pain, especially when it comes from areas with dense nerve networks like the roof of the mouth. As a result, the pain signals from the trigeminal nerve are interpreted as coming from the forehead or temples, even though the actual source is in the mouth. This phenomenon is known as referred pain and explains why brain freeze feels like a headache. Why does brain freeze happen so quickly? One of the most intriguing aspects of brain freeze is how quickly it occurs. The entire process, from the moment cold food or drink touches your mouth to the onset of pain, takes just a few seconds. This speed is due to the rapid response of the nervous system and the body's reflexive mechanisms. When cold stimuli are detected, the body reacts almost instantly to protect itself. The blood vessels constrict to prevent heat loss, and the nerves send urgent signals to the brain. Because the trigeminal nerve is so large and highly sensitive, these signals are transmitted rapidly, leading to the immediate sensation of pain. Who is most likely to experience brain freeze? While anyone can experience brain freeze, some people are more prone to it than others. Factors that may increase the likelihood of brain freeze include 1. Eating or drinking too quickly. Consuming cold items rapidly increases the chances of triggering brain freeze. The faster the cold substance hits the roof of your mouth, the more likely it is to cause a reaction. 2. Sensitivity to cold. Some individuals have a heightened sensitivity to cold temperatures, making them more susceptible to brain freeze. 3. Genetics. There may be a genetic component to brain freeze, as some people seem to experience it more frequently or intensely than others. 4. Migraine sufferers. People who suffer from migraines or other types of headaches may be more prone to brain freeze. The trigeminal nerve, which is involved in brain freeze, is also implicated in migraine headaches. How to prevent brain freeze. If you're someone who frequently experiences brain freeze, there are several strategies you can use to prevent it. 1. Eat slowly. Taking smaller bites or sips of cold foods and drinks can help reduce the risk of brain freeze. Allowing your mouth to warm up between bites can also help. 2. Avoid direct contact with the roof of your mouth. Try to keep cold foods and drinks away from the roof of your mouth and the back of your throat. Using a straw can help direct liquids past these sensitive areas. 3. Warm up your mouth. If you feel a brain freeze coming on, press your tongue against the roof of your mouth. The warmth from your tongue can help normalize the temperature and alleviate the pain. 4. Choose warmer treats. Opt for slightly less cold desserts or drinks, such as milkshakes instead of ice cream, or chilled beverages instead of frozen ones. How to relieve brain freeze. If you do experience brain freeze, there are a few ways to alleviate the pain quickly. 1. Drink warm water. Sipping warm water can help restore the temperature in your mouth and reduce the constriction of blood vessels. 2. Breathe through your nose. Breathing in warm air through your nose can help warm the roof of your mouth and ease the pain. 3. Press your tongue to the roof of your mouth. As mentioned earlier, this can help transfer warmth to the affected area and speed up recovery. The evolutionary perspective. While brain freeze is undoubtedly uncomfortable, it may serve a protective function. The rapid constriction of blood vessels in response to cold could help prevent excessive heat loss from the head, which is critical for maintaining brain function. Additionally, the pain associated with brain freeze might act as a warning signal, encouraging you to slow down and avoid consuming extremely cold substances too quickly. Brain freeze. In popular culture, brain freeze has become a well-known phenomenon, often depicted in movies, TV shows, and advertisements. It's frequently used for comedic effect, with characters dramatically clutching their heads after eating ice cream or drinking a slushie. While these portrayals are exaggerated, they highlight how universally relatable the experience of brain freeze is. The broader implications of brain freeze. Studying brain freeze can provide insights into other types of headaches and pain mechanisms. For example, the role of the trigeminal nerve in brain freeze is similar to its role in migraines and cluster headaches. Understanding how cold stimuli trigger pain responses could lead to new treatments for these conditions. Additionally, brain freeze serves as a reminder of the intricate connections between the body's sensory systems and the brain. It showcases how the brain interprets signals from different parts of the body and how these interpretations can sometimes lead to unexpected sensations. Next time you indulge in a cold treat and feel that familiar icy pang, you'll know exactly what's happening inside your body. And with a few simple strategies, you can minimize the discomfort and get back to enjoying your dessert. Brain freeze may be a fleeting annoyance, but it's also a testament to the incredible complexity of human physiology. If you enjoyed this video, make sure to subscribe to this channel for more content. Thank you.